Welcome back. This is online Math 256, Week 8 Integers, Part 2. So now we're going to talk about patterns in multiplying and dividing integers. So if you get your multiplying integers worksheet out and follow along, that would be great, and you can complete it as you go. So once you have that worksheet with you, read the directions carefully. It says complete problems 1 and 2 by completing the products you know, then look for patterns to fill in the missing entries. So for example, this first line says 4 times 3 equals 12. This next one we should be able to fill in because those are whole numbers. So 4 times 2 is 8. And then this next one, 4 times 1 is 4. And then stop right there before you just keep going and think about the patterns. So look down this first column. They're all 4s, so you're going to fill in these last 3 blanks with 4s. This second column, you can see a pattern. It goes 3, 2, 1. So the pattern there is it's decreasing by 1 each time. So continue that pattern down this. So that would be 0, -1, -2, -3, -4. Now remember, you have these first 3 filled in, 12, 8, and 4. If you look down this column, you can see the pattern that you're subtracting 4 each time. So 12 minus 4 is 8, 8 minus 4 is 4, 4 minus 4 is 0, 0 minus 4 would be -4, and do it that way. Don't look at the multiplication sentences until after you complete it with patterns. Then do the same thing on number 2. This time, notice that it's the second number that's repeating. So it's 5, 5, 5, 5, 5. And then so you're going to enter 5s for these last 3 numbers. Then it has 2 multiplication problems done for you. 4 times 5 is 20, and 3 times 5 is 15. So what would you put here for something times 5 is 10? Well, you would put a 2 here. So then you can look down this column and you can see it's that same pattern decreasing by 1. So 4, 3, you're going to write a 2, 1, 0, -1, -2, -3. Then in this last column you can see it's 20, then 15, then 10. So this column is decreasing by 5. So you would write a 5, then a 0, then a -5, a -10, and a -15. Now notice I wasn't having you do the multiplication. I was just having you fill it in with patterns. So after you complete it with patterns, what I want you to do is write a rule for multiplying a positive and a negative number. So try that. So if you look at this next slide, this is what you have filled in, and I hope you've written down a rule for multiplying a positive and a negative number. So that would be this part of your patterns, right? Because the first number is positive, then the second number is negative. What do you notice about all the results or the products? Over here, the same thing, but this time it's in a different order, which we know is the commutative property. So we're reviewing those properties as well. But so you have the negative number as the first factor, a positive number as the second factor, and then what do you notice about the result? So I hope you're writing a good rule in there. Now we're going to move to the bottom of the worksheet. So now you're going to believe your rule. You believe that your rule for multiplying a positive and a negative value. So now you're going to complete numbers 3 and 4, again using products that you know, and then filling in with patterns. So notice this time our first factor is a -3. So these 2 slots would be -3. This second factor is decreasing by 1. So we're going to go 2, 1, 0, then we're going to go -1, -2, -3, -4. In this last column, since we know our rule now for multiplying a positive and a negative, we know that -3 times 1 is going to be -3, -3 times 0 is 0, and then right here is the key. We're increasing here. So we have -6, -3, 0, so we're increasing by 3 each time. So this is a key right here, that this value will be a +3, and then a +6, +9, and +12. On number 4, we just reversed the factors again. So this time the second factor is negative. This time it's a -6. They did not fill in this first one, but this is something we should know now, that 3 times negative 6 is negative 18. And then notice that negative 18 to negative 12 to negative 6 is increasing by 6 each time. So negative 6 plus 6 would be 0, plus 6 more would be 6, plus 6 more would be 12, plus 6 more would be 18. This column here is decreasing by 1. So it would go 3, 2, 1, 0, negative 1, negative 2, negative 3. After you do that, you should be able to write a rule for multiplying two negative values. So a lot of you might have asked your teachers, why is it that multiplying two negatives turns into a positive? And your teachers may not have been able to give you a sufficient answer, because when you try to put it in a contextual situation, it doesn't really fit, or doesn't fit well in our brains. But if you look at patterns, it's the way it has to be, and kids can prove this. It's not a formal proof, but they can prove it through patterns. So here is that sheet filled in. So this is what you really want to look at. I have a negative first factor, a negative second factor, and what do I notice about my product? Over here I have a negative first factor, a negative second factor, and then what do I notice about my product? So there is a couple more things on that sheet, and you can just keep following along. Some of it might differ a little bit, but you should be able to fill them in. So in addition to looking for patterns, we can also multiply integers using integer chips or a number line. I don't love the model of integer chips or the number line. I prefer to use patterns, but I do want to show you how the model isn't terrible for some of these. So if we were going to use a number line to evaluate 3 times 5, I want you to go back to your whole number scenario and remember that would be 3 copies of 5. So I could model that on my number line. Here's 1 copy of 5. Here's 2 copies of 5. So 3 copies of 5, and I would end up at positive 15. Down here, I could do it with integer chips. So number of groups or copies, that's 3. The number in each group or copies are 5 positive chips. So I could put out 5 positive chips, and then I could do 3 copies of that. That would give me a positive 15. So I show you that in this next slide. There you go. You can see my 3 copies. And this helps you remember repeated addition, right? So 5 plus 5 plus 5 is 15, and you can see it on the number line. What if we have 3 copies of negative 5? Same idea, just in the opposite direction. So there's 1 copy of negative 5, 2 copies of negative 5, 3 copies of negative 5. With chips, I would have groups of negative 5, so I would have red chips this time, but I would have 3 copies of 5 red chips, so my answer would be negative 15. All right, here's where it gets a little messier. So negative 3 times 5, if we use our model for multiplication, we would say negative 3 copies of 5. But that doesn't make sense. How do I make negative 3 copies of something? Now, I could use the commutative property and switch the order of my factors and do 5 times negative 3, and that would be 5 copies of negative 3, and I would get the same answer, but my picture wouldn't be the same. So you can work around it using the commutative property. The other thing you can do is you can ungroup that negative sign to that 3 and think of it as the opposite of 3 copies of 5. So then you would do 3 copies of positive 5, and then you would take the opposite of it. I don't love this model, but it is possible. So there's my 3 copies of positive 5, and then I take the opposite of it. So there's my positive 5. I make 3 copies of it. Now I take the opposite. My answer must be negative 15. What if I have negative 3 times negative 5? Again, this is where the meaning gets a little messier. Negative 3 copies of negative 5. So I could do the opposite of 3 copies of negative 5. So I would do 3 copies of negative 5, and then I would take the opposite of it. So this is what that would look like. And you could imagine doing it with the actual chips, putting them out, and taking the opposite would be turning them over. All right, let's look at division. 12 divided by 4. These are whole numbers, right? So we've actually looked at this model previously, but maybe it wasn't clear on a number line, or we want to think about it this way. So I want to break it into groups of size 4. So I'm going to see how I can get to 12. So there I have 1 copy of a group of 4. There I have 2 copies of a group of 4. And then I have 3 copies of a group of 4. So my dividend is 12. My divisor, or my group size, is 4. And then if I circle those divisor size groups, this is what it would look like. So you can see there I have my dividend of 12. My copy size is 4. So I have 4 in each copy. How many copies can I make? I can make 3 copies. With negative as your dividend and negative as your divisor, it's still not terrible, because you say, okay, I have negative 12 and I want groups of negative 4. So I could have 1 group or 1 copy, 2 copies, and 3 copies. So with chips, you could see it, I have negative 12 chips, and then I want them into groups of size 4. So I have 1 copy, 2 copies, and 3 copies. So negative 12 divided by negative 4 is a positive 3. Now, connecting multiplication and division, we've been doing that. We want to talk about it in terms of the copies of. Remember, down here, it gets a little messier, right? When we're doing, okay, I have negative 12 and I want to put them in, I can put it in 4 groups, which would be easier, so then I could see it. This one, I want positive 12, and I want either groups of negative 4 or I want negative 4 groups. That one doesn't fit as well in there. So this model doesn't model this last one very well. But you can always change it to a multiplication problem, and it's the missing factor model. So 4 times what gives me 12? Or negative 4 times what gives me negative 12? 4 times what gives me negative 12, or negative 4 times what gives me 12. So it's a nice way to look at connecting multiplication and division. The rules for multiplication and division are the same, so it's nice once you formulate the rules for multiplication, they apply to division. Now this is going to be a flashback. How do I multiply 2-digit numbers? This is on your worksheet. Once you figure out the answer to this, then you can apply your rules about integer multiplication to complete the rest of the problems. So try an alternate strategy for 14 times 23. In this case, I used the expanded algorithm, or writing it out, and I got 322. Now I can fill in all the rest of the answers on the worksheet where I know, oh, if one of the factors is negative, then my product is negative. If both of the factors are negative, then my answer is positive. It's funny because sometimes kids will work out the same problem 4 times, like you see on the worksheet, where they just really know that all that is changing is the sign. Here's your next one, 25 times 32. Try a different strategy. This time I used the area model, and I did 25 times 32, and I got 800. Some of you might have related it to money and gotten that same answer, or you might have used one of the other algorithms we did. But now you can answer the rest of those questions. Here's just another practice. So there's 215 times 16. I don't think that's on your worksheet, but it's good to practice that. A division problem. I think we did this division problem with our base 10 blocks, but it's nice to revisit it with some scaffolding, or the big 7 partial quotients. So I got 141, and then I should be able to answer the rest of the questions. Same with 462 divided by 3. I used partial quotients again, and I got 154. There is part of your video assignment is on exponents, and the reason it's in this section is because a lot of us get confused on, does that negative sign get applied to the exponent or not applied to the exponent? And so what does it look like in expanded form? How would I say it in words? What is the factor language and what is the math equation? So you have a video on this, so make sure you complete that assignment. And these two are not the same answer, and that has escaped some students before. They think it's a new rule, and it is not. This last thing I wanted to remind you of, you did order of operations already, but I just wanted to remind you that you have to be really careful when you're doing it with integers so you don't make a mistake, right? So try these 6 problems. Notice that some of them have just addition and subtraction, some of them just have multiplication and division, and some of them even have exponents. So try these and then check the next slide to see if your answers are right. All right, how'd you do? Did you get them all right? If not, make sure you pause this, go back to the previous slide, and make sure where you made your mistakes. That's the end of week 8. We are halfway done with this course. Good job. Make sure you're studying for your midterm and that you get all your assignments done. All right, good luck studying.